And I'm going to inductors basically now. And I just want to show you the first inductance formulas. Basically, it is two inductors in parallel. It's 1 over L1 plus 1 over L2. It's just like resistors in parallel. In series, we just add them up. L is L1 plus L2. Now, to make an inductor, we can calculate the inductance, and we use this formula. The inductance L equals permeability in free air times relative permeability, which is mu r, times area times n squared over the length. So let's start. Mu naught is 4 pi times 10 to the minus 7, like you've seen there on top. Mu r is for this core material. Mu r will be have a relative value. Iron is about 1,000 and nickel is about 2,000. Depends what material we use. I will always give that to you in the exam. The relative permeability. The area is, if I cut this thing through in half here, then that area, cross-sectional area that is there, that is your area, and it's in square meters. Don't use square millimeter, don't use square centimeters. It will be wrong. Always convert to square meters. Remember that there's 1,000,000 square millimeters in a square meter, not 1,000 like you think. The 1,000 thing is there's 1,000 millimeter in a meter, but there's 1,000,000 square millimeter in a square meter, and there's 10,000 square centimeters in a square meter. Those unit conversions is on page 17 in the handbook. Just learn them. So now that we've talked about the area, n is the number of turns here. So the turns here is 1, 2, 3, 4, 5, 6. So 6 squared is 36 here. That'll be a 36. Divide by the length. And the length is the circumference of the score. The circumference is 2 pi times radius. The average circumference of the score. We don't take the inner circumference. We don't take the outer circumference. We calculate the average circumference. You do that by taking the outer circumference plus the inner circumference, divide by 2. That will give you the average circumference. Okay, now I'll quickly go and just do this formula again. And this is the charge formula quickly again. We charge an inductor not with voltage, but with a current. So the charge current will be this. That will be I max, or that'll be what they call it, the final current. I max is the same as the final current. It's a stipple line. And you can see that red curve never reaches the stipple line. It never ever reaches the stipple line. And so it charges up forever to reach that stipple line. It's a because this is an exponential curve. Exponential curve, I've got a final value, but it never reaches that final value. Right. So I is V over R is voltage divided by resistance, which gives you that final current, voltage divided by resistance, times E to the minus T over tau. Right, on page 202, I encourage you to read the book on that page and explore this formula again. And also remember, in the exam, I can ask questions that in the book. I ask questions out of that book. If you don't read those pages in your charge the current up to that value, say It's 1 ampere is the final value. So say we've only chosen 12 ampere, 0.5 amp. Then we will use that value here, 0.5 ampere, when calculating the discharging. Now, right. Guys, can you still hear me? Can you still hear my voice?
Yes, sir.
Yes, sir.
Thank you very much. This thing said poor sound quality, so I thought the voice is wrong. All right, so I just recapped quickly what we've done yesterday. There is a video which I'll send to Sibonello for yesterday, and you guys can look at that full video. So this is just a recap. Also, these formulas on page 197, page 201 and 205. Revisit them and do them. So the voltage over inductor is the voltage is the current times the change in current over the change in time. So if my current changes from 10 ampere to 20 ampere, that will be 20 minus 10. So di will be 10. So di is the change in current. If I go from 9 ampere to 15 ampere, my current change was 6 ampere, 15 minus 9. The change in time will be how fast did I change the time? If it's a millisecond, then this time is 0.001. So the voltage is directly proportional to the change in current, but indirectly proportional to the time. The faster the time, the higher this voltage will shoot up. And this voltage will shoot up even to 1,000 volts or 100,000 volts. And you can do it in the lab. You can, in front of your eyes, you can see what happens when you do that. Just take note, it can shock you if you touch that coil wire. It can shock you. So the time constant is L over R. For capacitors, it's very similar, but there it is RC. And so tau is L over R. Inductance over resistance. Read page 201, the whole page. Like I said, they'll explain these things on those pages, and I'll ask questions out of this on those pages. You might not know what I'm asking if I ask those questions, if you don't read this. So the energy inductor is similar to capacitor. For capacitor, half CV squared. Here it is half inductance times current square. Current to the power of 2. That's what that square means. So if it is 10 ampere, you can't say it's 10 here. You must say it's 100 times 100 here, because it's current square. All right, guys, I'm going to stop with this now, and I'm going to go. I'm going to share now my some questions that you can do in class. We've done the theory now. So let's share. Stop sharing this, and then I just want to open my questions that I have here. And a few problems that you can do. Get yourself your paper ready, and let's do this one. Right. Just want to share this problem. It takes a while to do sharing. It's really difficult. Can you all see this problem? Can you guys see that?
Yes.
Yes, sir.
Yes, sir.
All right. So please do it for me. 15 ohm resistance and a 7 Henry inductor is connected on a 32 volt supply. What is the time constant and what is the final current for the circuit? They are in series, né? All of them are in series. So do that and someone tell me when they've got the answer. I'll give you all a chance to try this one out. So put up your hand, raise your hand if you've done it. Guys, are there any hands to raise? What is the time constant, please? Shall over all people. So it's very simple. It's 7/15, so it's 0.5, right? 467 milliseconds. You see it there. Right. What is the final current? The final current is the voltage divided by the resistance. So we've got 32 volts. And we've got 15 ohm. And 32 by 15 is 2 ampere. Right.
2.33.
How much? 2 point?
2.133
Thank you very much.
amps.
Yeah. I just divide 32 by 15. I get 2 because I don't use a calculator. But that's the very accurate answer. Thank you very much. Okay, let's do another one. So here we've got another one. The current through a coil have a resistance of 6 ohm, an inductance of 2 Henry, and the current is 4 ampere. What is the instantaneous value of the current after the source is short circuited? In other words, what does that mean? We are discharging it. Do you agree?
Yes.
So we're starting at a 4 ampere current at that moment, and we're short circuiting. So what is the current 50 milliseconds after it was short circuited? I'm trying to get a paper here. So I can write. Guys, can you see my pen here? People, can you see the pen moving here or not?
Yes, we can see the pen, sir.
So
Don't see.
we're going to discharge now. So, the current, it's a current, eh? The current for discharging equals. Remember my formula that I teach you is I final or I max what it was. In this case, it's 4 ampere times E to the minus T over tau. Very simple. So this is the 4 ampere. And you know what is tau? What is tau? Who can tell me what's tau? The time constant? What is tau, guys? Tau over R. What is tau? Who can do it for me? Is there anyone that's capable of calculating the time constant?
2/6, sir.
Thank you very much. Guys, why does it take so long? 2/6, which is 0, a third, which is 0.333, ne? You got it. So you plug that into there. The time, what's the time? 50 milliseconds. How much is 50 milliseconds? In seconds now. You've got to work in seconds. You can't work in milliseconds, right? Convert it. How much seconds is it? Who can tell me?
50 times 10 to the negative 3. Milli.
Don't say the 10 negative 3. That is for more school children, eh? What is the real answer we do in TUT? The engineering unit. What is it? Don't say negative 3. 10 to the negative 3. How much is it? Engineering unit. 0, now the time.
0.05.
Thank you. 0.05. That's 50 milliseconds, ne? So you put 0.05 in there over 0.33. So it's very simple. So what is the discharge current there for, guys? How much? Or must I show you? Do you see how to do the time constant? And it's the issue current. 3.4 ampere. Okay. Have you got it? You see how the 50 milliseconds written there on top and the 330 milliseconds on the bottom, and then you get your current. All right. Any questions on this one? Good. Let's do the next one. Let's see if you can do that. There's the answer. So we've got a field winding of 440 volt for a DC machine. So what is the EMF induced in the winding? If we cut the current at half a second, so the time is half second, 0.5 seconds. Can you do that for me? What is the voltage generated? So this formula is V equals L di dt. L di dt. L is 35 Henry. What is di? What is the change in current, people? Who can tell me? I'm not telling you. What is the change in current? What is the current here? in this problem? There's a current. What is it? Can someone try?
Sir,
Yes.
can you say 440 divided by 100?
Thank you very much. What's your name?
Renee, sir.
Sorry?
Renee.
Nathan, thank you very much. You are very clever today. So do it now. Calculate what's the voltage now. And tell me. What do you guys get for the voltage? We will just do it on your calculator. This is very quick to do. I don't know why it takes so long. What is the time? The change in time? Come guys, it shouldn't take that long. You know the L is 35. The current he just said now, it's about a quarter amp. 400 volt over 100 is 0.25, guys. And 440 over 100 is about 0.27 or something, whatever. Just do it and calculate us the voltage. What do you get? Okay, guys, I'm waiting for the first one to answer me. Otherwise, I will not carry on. I will wait here forever. How much did you guys get? $35. The current is 0.25 about, and the time is 0.5. It's only three things. Calculator, put that one in, put that one in, put that one. What is the answer? No one knows. No one knows today. Is there someone that wants to try and give us the answer, please? Sevenero, what's your answer? Eh? Okay, people, does anyone have an answer? Or you cannot do this at all?
Can I try, but can you see this?
Mr. Baloy, what's the answer?
This is supposed to be 15.2.
Let's say again.
15.29.
Thank you very much. You're the first one. I don't know why nobody's interested in this one and why they take so long. So there is your current, 4.4 amp, not 0.25, sorry, 4 ampere. And there is your voltage. 35 times 4.4 divided by half. Ne? So it's minus 300 volt. Remember the minus? Remember that when we discharge an inductor, the voltage is always negative. So that's why it's a minus 300 volts. Do you see? Okay. The next one, let's see what it
Repeat that,
is.
sir.
Hmm?
May you
Say
repeat
again?
that?
What must I repeat?
Why
What
the
must I
answer?
do? When you charge an inductor, the current goes from, say, left to right, right? But when you discharge it, the current goes from right to left because it's discharging that same current. The direction is now minus. Do you see? So we must put a minus in front of that 4.4 amp. A minus here. And when you put a minus there, it's minus 308 volts. Because your current is in the opposite direction as when you charged it. You understand?
Yes, sir.
Thank you. Let's keep this one. Let's skip this one. I'm going to skip that one also. Skip this one. Okay. Let me remove this document and put another one on. And so I've got some more examples which you can do. And there it is. So guys, do that first one. (6.1). The current through a coil changes from 1.8 to 0.5 amp. So it's reducing. Do you see that? In 1 millisecond. The voltage is 35 volt. What is the inductance of the coil? So that same value, that formula, V is LD IDT. What is the inductance? Can anyone tell me? What is that inductance, people? Well, you're wasting a lot of time. I still have a lot of problems to do. Another 10. So if you're going to sit another 3 hours here, it's fine with me. Or you can decide to participate. So please tell me, what is that inductance?
Isn't it 27.788?
7.7. Okay, let's see what it is, the inductance. I'll have to find the answer now. I've got it somewhere here hidden. Okay, there it is. We're having a current 1.8 ampere. We're reducing to 0.5 ampere. So the change in current is how much? Minus 1.3. You see, 1.3 is your current. So L is the inductance, it's 35. So it's sorry, L is, what am I talking? So that voltage is 1.3 times L over 1 millisecond. That's 1 millisecond. Eh? And therefore, it is that over that, so it's 26.9 millihenry. Did you all see the answer? What was your problem? Why you got a different value? Just explain to me, where's the mistake?
On the change in current, I didn't route it to 1.3. I just left it as that.
Okay, if current was different, but you see now how to do this now.
Yes.
Thank you for responding. You're the only one that participates in class, actually. Guys, you must also participate, even if you're wrong. Like you see, I don't discourage her or fight with her because she's wrong. I simply ask, where did you different from me? And that's all we want to know. We can all learn out of this. So now the coil, that same is wound on a core with a diameter of 5 millimeter, the length of 12 meter, and the probability is 1,500. What is the number of turns in this coil? So remember now, we got to use that formula, which I showed you about the inductance. Let's write it down. Inductance is mu naught, mu r, times the area. Remember the area in square meters, times n. I think it was n squared, divide by the length. So use your formula and then calculate for us. What is it? So now you can calculate, you've got the inductance, right? So mu naught, what is mu naught?
What is
4 pi
4
times 10, yeah, minus 7, eh? Mu r, what is mu r? Who can tell me?
1,500.
This one, 1,500, eh? Times the area. What is the area? The diameter is 5. So remember, the diameter is 5. That is 5 millimeter. So what is the cross-sectional area? Is pi times radius square. So it's pi times the radius 2.5. 2.5 millimeter times 10 to the minus 3 square. We must square this. How much is that? Times the area times n, the number of turns. We've got to calculate n, eh? We don't know what's n. We must calculate that one. Divide by that length. And they say there the length is 12 millimeter. So 12 times 10 to the minus 3. So you do this formula. You make n the subject of the formula and you calculate it. What do you guys get for the number of turns? What do you get, guys? Is there anyone that want to try? Please, guys, don't waste time. Let's try. Even if you're wrong, it does not matter. Don't be so scared. Most of us are wrong. So don't be scared of being wrong.
Hello, sir.
Yes, sir.
I got a funny answer. I got like 0.18.
For
So
the
that-
number of turns.
Yeah, that doesn't make sense.
Yeah, maybe your area was wrong. This area is 5 times radius square. Eh? What was your area there?
I worked it out now, so I got 0.0. Wait, no, let me rather put it in. I got 19.
0.0?
No, so I got 19.635 times 10 to the 6. The negative 6.
For the area.
Yeah. It's quite small.
19
0.6
point
635.
times 10 to the minus 6.
Yes, sir.
E minus 6. Look how I write it. E minus 6 there. Which is times 10 to the minus 6. Okay, now that looks all right because remember that's square meters. And in this 2.5 millimeter is the radius. It's very, very small. So that is correct. That's not your mistake. Did you times 4 pi times 10 to the minus 7? 4 times 5 is about 12, nee? 3 times 4 is 12. 12 to the minus 7. That's simple. Times 1. Okay, at least that's a try. Let's look at what it was, actually. Maybe I am wrong. We never know. The lecture's not always right, you know. I've got so many calculations and things worked out here. So there's your area. You were right with that 19. Do you see there? Do you see that 19? It's 1,9 times 10 to the minus 5, actually, which is right. And then to get n, you've got to take the square root of that. Maybe you didn't do that, did you?
So I see I left the 4 pi times 10 to the negative 7 out.
Yeah, that's mu naught. So,
Yeah.
so just do that. And can you guys now see the value of these lessons that we do over Teams? It's actually very learn some, and we can make mistakes and we can even fix them. So it's 93. In this case, 93,4. The terms will never be that much, so it's 93. So we just roughly want to know, maybe we got to calculate how big to make a coil. We want to make a coil for something like this thing, and we calculated that, so we use 93, the closest number. So that will be your number of turns that you must use for this problem. Let's do another one. You guys want another one? When must I stop, guys? When must I stop? There's lots here. Right, so the next question, there's an iron ring, you see there. Okay, I want the reluctance. You can't do it yet. I haven't done the formulas for reluctance. I'll do that like maybe on Thursday or Wednesday. The MMF, you can do that. MMF is NI, ne? Try that. Then H is the magnetic field strength. Remember, H was NI divided by L. So you can do that one. And the current is MMF is NI. You can do that one too. Because we've got N is 700. You guys want to try it? And then let's go to the solution and see. Question 2. Don't do the reluctance. We haven't done it with you yet. But the rest you can actually do. Right. Most people didn't know how to do this one. Let's just look at the answer and come back to question number 3. So here it is. The reluctance here is 7 million. Ne? Okay, the MMF is 657. That is, MMF is NI. And H is NI over L, 313. And the current is 0.94 ampere. Okay. We'll do this one later. I don't expect you to now. I just wanted to show you that it is doable, and this is how you kind of do this thing. This is sort of the formulas we'll have in the exam. These are all the formulas I will give you. I'll teach you these formulas like in the course of the next week or so. All right, but don't worry about that. And do question 3. It's easy. It's basically we want a time constant. Who can give me the time constant of question 3? The time constant is L over R. Who can tell me? 10 divided by 0.8, guys. It's like 10 divided by 1 is like 10, man. Huh? How much?
12.5, sir.
Oh, thank you.
12.5.
Yeah, you're more accurate than me. I just do it in my head. You have got a calculator. So 10 divided by 1 is about 12. Correct. The maximum value of the current, or the final value, we can call it the final value as well, remember, or the maximum current. What is that? Current equals voltage divided by
25
Resistance.
I got 23,
5.8 ohm, ne?
24. Sorry.
So that's slightly more than 20 ampere, ne? You guys, someone said 25 ampere. Let's look at those two answers, and then we do the third one, 3.3, so that we are sure we use the right values, right? And let's go to 3.1. There it is. So indeed, someone said 12.5. They were right. Very good. 2 marks for you, ne? 2 marks. 3.2. The current is 20 over 0.8 amp. It's 25 and 2 marks for you there. And then 3.3. Don't look. 2.3.3. Guys, the only way for you to make your brain cells grow, listening doesn't make it grow, but doing the problem really grows your brain cells. Just grow your brain cells, guys, and do it. Don't sit there idle, just do it. The instantaneous current, 4 seconds after connecting. After 4 seconds. So the current equals I max times 1 minus E minus T over tau. Do you still remember that formula? And we know what tau is. We did it. 12.5. We know that time is 4, ne? So that's a 4 and that is a 12.5. 4 and 12.5. It's simple now, we can do it. There's no, and the max current you guys gave it to me was how much? 25, wasn't it?
Yes.
So come guys, this is now a matter of calculator. What's the answer?
$6.85, say. I got 6.85.
Ah, did I hear? Some
Six-
enlightened voice here. How much?
6.85.
6, ne? Let's see,
Six.
someone said 6.
6.84.
Let's have a look.
6.84.
Let's have a look. Oh, we got it, ne? We've got it.
Yes.
We are getting clever now. 6.8, you were right. Another 3 marks. You see how you earn marks here on the question paper. Can I tell you a tip, guys? This question, this one, little different. Is on the exam, just like this. I'm just changing the values. So you can't copy this one. Right. Let's do the last one. The EMF induced in that coil. If the current, that 6.8 ampere is reversed to 3 no, it's reversed. We're reversing that current. So what we're doing, we're making it 0. We reverse that current, so it will be a minus voltage, né? Firstly, we're reversing the current, so the voltage will be minus. Remember, it's a vector, and a vector has got an arrow or a direction. That's why it's minus. So what is the voltage we will generate in half a second? That one was that formula. V is L di dt. Very simple, not very difficult either. So punch it in. What do you get?
So I got negative 624.2.
Amazing. How can you generate 600 volts from a 20 volt battery? Did you ever think of that? You remember you only have a 20 volt battery here. How can you get 600 volt out of it? Don't you think that's funny? What do you think? What happens here? You do, but I'm just asking. You started with a 20 volt battery, now you're ending up with 500 volt. You can shock someone. What are you building? A shock machine. Hey? Okay, there it is. So 10 times 13. Okay, I must just see why this is 13. You are probably right. And the time here is let's just see what's the time 3. Half a second. 0.5 here. So an inductance is 10 Henry and the current difference is 13 amp. So it looks to me they've reversed double that current. It took double that current. Do you see? The question says the current calculation is reversed in. So what they actually mean by reversed? It's a catch question, this one, eh? It's like a, they're reversing the current. In other words, they're reversing the same value in the opposite way. So it's the same current, and that is why they add the two currents together. So it's the current plus the reverse value of that same current, which is double the current. That is why your answer is a little bit out. But basically your answer is right with that answer. Okay. Because, right guys, do you want more or can we stop? What do you want? Tell me. I'm tired.
We want
Who's
more.
tired?
More, sir.
Could you please do that?
I'm not
Wow.
tired yet.
Last question is.
Who wants to go home?
We
Who
want
wants-
more.
We are tired.
Okay, okay,
We
let's
want
see.
more.
Okay,
Don't
More.
move.
let's look
More.
at this one. I'm basically finished actually, but let's quickly look at what this one gives us. Let me just share it here. Oh, I've got it already open, but I have to still share it. See? There's some more examples of, let me just see what there is. Okay. We've got a question, we've got a core. And this core has got very complicated core. There's some wires winding, 1, 2, 3, 4, 5, 6 windings. Alright, and they wanted you to calculate the reluctance of sections A, B, and C. So this one is very complicated. You won't get this complicated one in the exam. But it's just good to see what we are still going to learn. So the reluctance, I will still teach you how to calculate the reluctance. Or something like this. And then first I want the reluctance and then I want the MMF. The reluctance is basically this formula. S is length over mu naught mu R area. That's your reluctance. So we'll still learn that formula. I don't expect you to do this problem now. And that's how they do it. So I'm not going to do this one now. My problem is a bit mixed, you see, so that's why we are struggling a bit. But I think we can do this one. This one, yeah. Let me hide the answer, but we want the time constant. We want the maximum value of the current, which is the final value. Or we want the instantaneous value of the current 5 seconds. So it's similar to the previous one. Guys, just in 1 minute, quickly do it. Tau is L over R. The current is V over R. And just do it quickly. What's your values there? It shouldn't take long. I'll do it in my head. It's 30 over 3, guys.
The
It's
current
10.
constant is 10.
Yeah, 10, thank you. And then the current,
The maximum current is 8.
yeah, thank you. So it's 20 volt divided by 3. You did, no? Did you do that?
Yes.
Very good, Miss. Is it Miss Baloy who's speaking?
Yes.
Oh, very good. And the instantaneous value? It's just that same stupid question we had just now. Unfortunately, I don't have that many questions. What we'll do later, we'll open Brightspace for you again. You can do another, like a quiz or something for practice, because there I've got a lot of problems there in Brightspace. You just don't know. I've got like 100 problems there, exam problems. When you guys are ready, you must ask me to let you do that. So what is your current there? 5 seconds, ne? It's about half a time constant, so it's about half 24 volt. I guess it's about 10 volt, ne? Let's see if I'm right. This is in my head, I do these things. What do you guys say? 8 volt to 10 volt, I would say, roughly. What do you get? This one. That's formula. How much? So there's your answer.
So I got 3.15.
Okay. You're right. I was wrong. I said 8 to 10. I was totally wrong. There it is. 3.15. And then your energy, half Li square. Just do it as well. So you can practice the energy thing. You know the current is 3 amp. So 3 times 3 is 9. Well, 3.1 times 3 is about 10 actually. More than 9. Did you get that? 1000 joules, roughly 960 joules. I'm going to do another one. Let's see if there's another one. Guys, now I think I'm at the end of this questionnaire. Yeah, I'm at the end of this questionnaire. So really, this is what we have to do. People, thank you very much for joining today's class. I think it was a very good class. And no comrades disrupting us. I don't know why. Did they dry up? People, is there still a strike on?
Yes, they went to a strike, sir.
You must go and help them, eh?
Yeah, sir.
Don't break the furniture. Just don't break the furniture. And do your homework. Okay. People, enjoy your day. Let me stop the recording.
No, I'm going to strike. Next strike.